Friends, last video we discussed about working principle of DC generator. So in this class we will discuss about working principle of DC motor. See, what is the working principle of DC generator? Rotating conductors are placed in constant magnetic field so that EMF is induced. But coming to DC motor, coming to DC motor, so what is the input for DC motor? Input is electrical, output is mechanical. See, here construction is same. Construction is same. Means this one is pole core, pole shoe, and field winding placed on. So let us given DC supply. If you give DC supply to the coil, what happen? Constant magnetic field is developed. So here also same. Constant magnetic field is developed. So here flux lines are passing from north pole to south pole. Flux lines are passing from north pole to south pole. Flux lines are passing from north pole to south pole. Flux lines are passing from north pole to south pole. So in DC generator also same. They are having two windings. One is field winding, another one is armature winding. One is field winding and another one is armature winding. For field winding, we will give DC supply. For armature winding, we will give see in DC generator we gave DC supply to the field winding. In DC motor also we gave DC supply to the field winding. If you give DC supply, what happen? Constant magnetic field is developed. That is, magnetic field flux lines are passing from north pole to south pole. It is common for both DC generator and DC motor. So here, see, for DC motor I will use Fleming's left hand rule for find out direction of mechanical output. That means force. See, here also forefinger represents direction of magnetic field. Here also forefinger represents direction of magnetic field. Understand? So in DC generator I used Fleming's right hand rule. In DC motor I will use Fleming's left hand rule. So here forefinger represents magnetic field. Here also forefinger represents direction of magnetic field. Both are same, but here I will use left hand. But in DC generator I will use right hand. See. So you know the direction of magnetic field. After that, this is armature conductor. This is armature conductor AB. This is armature conductor AB. This is armature conductor AB. This is armature conductor CD. This is armature conductor CD. This is armature conductor CD. So this is armature conductor AB. This is armature conductor CD. So they are also having, see, this is north pole, south pole. Flux lines are moving from north pole to south pole. So in between North Pole and South Pole, I placed two conductors. In DC generator, which input I gave to the armature conductors? Mechanical input. So if I gave mechanical input, what happened? Conductors are rotating. But in DC motor, what is the input? Input is electrical. Input is electrical. So I will give electrical input to armature conductors. Armature conductors. Armature conductors. I will give DC input to armature conductor. So here DC supply, DC current passes through brushes to current passes from DC supply to brush 1 to commutator. This is commutator. This is commutator. Brush 1 to commutator, commutator to conductor A, conductor A to B, B to C, and C to D. This is conductor CD, conductor CD. C. This is the direction of conductor C. C. After point D to brush 2. So this is the direction of current. So current flows from positive to B1, B1 to commutator, commutator to A, A to B, B to C, C to D, and D to B2. So this is the direction of current. This is the direction of current. So let us, if IAB is cross, here current is leaving. Means initially here current is leaving. But after half rotation, what happened? Current is entering. Clear? So which type of current passes through the coil? AC. Which type of current passes through the coil? AC. But what we are giving? DC. What we are giving? DC. So here what is the function of commutator? Which is converting from DC to AC. Commutator converts from DC to AC. In DC generator, what is the function of commutator? In this in DC generator, function of commutator is converting from AC to DC. But in DC motor, which is converting from DC to AC. So which type of current passes through the armature conductor? AC or DC? AC. AC. So whenever the alternating current passes through the conductor, what happened? Alternating magnetic field is developed. Alternating magnetic field is developed. This is alternating current. So which type of magnetic field is developed? Time varying magnetic field. Time varying magnetic field is developed. Time varying magnetic field is developed. So here two magnetic fields are available. One is constant magnetic field, that is due to field winding, and due to armature winding, time varying magnetic field is available. So due to interaction of these two magnetic fields, what happened? Force will be developed. Force will be developed. So what is the resultant? Resultant is force. Resultant is force. So what is our target? What is our target? What is our target? We have to find out the direction of force. So here, what is the working principle of DC motor? Working principle of DC motor. What is the working principle of DC motor? So here conductor is now it is current carrying conductor. Now it is current carrying conductor. Now it is current carrying conductor. In DC generator, rotating conductor. DC motor, it is current carrying conductor. So what is the working principle? What is the working principle? Working principle is whenever current carrying conductor current carrying conductor placed in constant magnetic field, what happen? Constant magnetic field, what happen? Torque will be developed. Torque or force will be developed. Force. Sorry. Force will be developed. So how you will find out the direction of force? By using Fleming's left hand rule. By using Fleming's left hand rule, you can find out direction of force. See, here forefinger represents direction of magnetic field. Middle finger represents direction of current. See, this one is current is leaving. This one is current is entering. This one represents which is leaving away from me. So that current is leaving, which is entering towards us. So which is entering direction, which is leaving, which is entering. So this is constant magnetic field. Flux lines passing from north pole to south pole. Okay. So in conductor AB, see this is conductor AB. Here what is the direction of current with respect to, this is point A, this is point B. Current is passing from point A to point B. See here current passing from point A to point B. Point A to point B. This is point A, this is point B. So what is the direction of current? What is the direction of current? Which is leaving from me, leaving away from me. Means how you will represent the direction of middle finger? This one or this one? Leaving, with respect to me it is leaving. So this is direction of current. What is the direction of magnetic field? This one or this one? No doubt this one. Direction of magnetic field. So what is the direction of force? Direction of force should be downward. Direction of force should be downward. Clear? Clear? So here direction of force is downward. Direction of force is downward. But in another conductor, what is the direction of current? Here current is leaving. Here current is entering. So how you will represent the direction of current? This one or this one? This one. What is the direction of magnetic field? This one. What is the direction of force? Upward. What is the direction of force? Upward. Clear? Clear? So in another conductor, direction of force is upward. Direction of force is upward. So in conductor AB, direction of force is downward. In another conductor, direction of force is upward. So how it is rotating? Moving in anti-clockwise direction. Moving in anti-clockwise direction. Moving in anti-clockwise direction. So how you can find out the direction of force? By using Fleming's left hand rule. By using Fleming's left hand rule. So what is the difference between DC generator and DC motor working principle? In DC generator, conductors are input given to rotor. Which type of input? Mechanical input. So that conductors are rotating. So rotating conductors are placed in constant magnetic field. Here constant magnetic field is same in DC generator and DC motor. But in DC motor, for the same conductor, which input I am giving? Electrical input. So that now it is current carrying conductor. So which type of conductors are placed in constant magnetic field? Current carrying conductors are placed in constant magnetic field. So what is the working principle? Current carrying conductors are placed in constant magnetic field. Torque will be developed. Force will be developed. So we can find out the direction of force in motor. But in DC generator, these are rotating conductors. So rotating conductors are placed in constant magnetic field so that EMF is induced. EMF is induced. That is the working principle of DC generator. And working principle of DC motor is whenever the current carrying conductors placed in constant magnetic field, torque will be developed. Torque or force will be developed. So this is about working principle of DC motor. And constructional details we will discuss. Okay. So this is about working principle of DC motor. Thank you. The next video we will discuss about constructional details. Thank you.